Okay, so in this section you'll be creating a sample application using Scala. Okay, you're going to be using a subset of a data for taxi trips that will determine the top 10 medallion numbers based on the number of trips. So I'm just cleaning up and closing all the windows now. And you can start up a new one. So for this exercise, you're going to have to load 2 additional taxi data into the HDFS, and it will be under the temp directory. So let's go ahead and create 2 additional directories. So I'm creating a lab data directory under the temp, and I'm going to create a Spark data directory under that lab data directory. You can of course chain this together into one command, but I wanted to show you separately. Now you're going to upload 3 CSV files under the Spark data directory, namely nyctaxi.csv, nyctaxisub.csv, and the nycweather.csv. We're going to use 3 Hadoop commands to put the files on the HDFS under the Spark data directory. So the taxi data is actually some taxi information from New York, and that data is going to get loaded onto the HDFS. It's going to take a while. The file is actually quite big. Okay, and now we're going to load in the taxi sub data. This is a subset of the original one. So we're going to use the original one for this particular application, and then the other 2 will be used for a later exercise. We're just loading all 3 of them now. And then finally the NYC weather. Alright. So let's make sure that all the files were successfully loaded. Do a listing of the Spark data directory. Alright, everything looks okay. So we're good to go. Let's start up the Spark shell. And of course, the first thing you're going to do is create an RDD of the NYC taxi file. Everything we do in Spark is going to consist of an RDD. And if you wanted to, you can take a look at the first 5 rows of content, use the take5 method, and print it to the console. Essentially, once you print it out, you're going to see the header columns and the data after the header. So there's information like the medallion, the passenger count, pickup date time, pickup location, latitude, longitude, information like that. Now typically we would want to remove the header from the file, but because the operations that we're going to be doing won't get affected by the header, we're going to leave it in there. It's not a big deal. And also, when you load in some type of input file, you're going to want to just going through each of these different columns here. So with this information, you can determine the medallion numbers and the number of based on the number of trips. So top 10 medallions based on the number of trips. That's what we're going to find out here in this lab exercise. Okay, so now you're going to parse the information up, split it up by commas, and that's going to be a parsed version of the data, so that way we can work with it. And next you're going to want to create some key value pairs from the data where the key is the medallion and the value is 1. So we're going to use this model to later sum up all the keys to find the number of trips a particular taxi took, and in particular we'll be able to see which taxi took the most trips. So here we are. We're going to parse it up further to get out the key, and the val6 is the medallion number, and the val1 corresponds to the value. So basically mapping 1 to the key, right? Or key to the value of 1. Next we're going to do the reduce by key function, and that's going to add up all the keys for a particular taxi. So you're going to see how many times this taxi was recorded. Okay. And the values that are actually swapped when they come out, so we have to reorder them in descending order so that the results can be presented correctly. So that's what this line here is doing. It's going to swap it back around, and we're going to get the top 10 of it and then have it printed out to the console with our formatting here. So you'll see in a second what that looks like once it comes out. Alright, so you can see the different medallions, their number, and the number of trips they took, and we were able to sort it by the top 10. So this medallion on the top had 415 trips, the second one had 411 trips, so on and so forth. I mean, all the steps above we did on separate lines. You can obviously chain everything together and use the shorthand notation. So here's what I'm showing now. Putting everything on one line, you're doing the splitting by the comma, then mapping up the medallion keys to 1, and then reducing by the key. And obviously in an actual application you're going to want to be concise, but for debugging purposes it might be useful to break up the individual operations. And I'm just running the same print statement out on the single line to show you that it will produce the same results. Okay, you'll see the values within this info printed here. And if you scroll up a little bit, you're going to see the top, actually it's right there, the 415 trips for the first medallion is just one line above the 411, and that's just due to the printout of the logs. Went ahead and cache the taxi medallion one line count. You run the count on it to actually invoke the cache, and you can run it again to see that it is indeed faster because it ran against the cache. But again, not by much. If you had more data, obviously it will make more of a difference.